Welcome to Geometry for AP. Today, this lesson is about more proofs with segments and angles. You have all the building blocks from the other day, and so those are used in proofs over and over and over again in just different ways. And so these are the last few proofs of building blocks. These are a little more complex. These are used in bigger proofs to do more complex things, but I want you to have them in your notes so that you can see them when they're used later on when we're doing other triangular proofs that we're getting to. So our first one is that we're going to prove that CA, and I'm going to use a highlighter for this segment right here is congruent to this segment right here. CA is congruent to CE. Now, that's what they want us to prove. And in this problem here, it tells us that CB is congruent to CD. It tells us BA is congruent to DE. So we know each of these parts are congruent, but we don't know that the whole things are congruent. You can see that they have the same marks, and so logically you can think that, hey, those are going to be congruent. But you've got to prove it, and you've got to do it using algebraic properties and things like that. Okay, now the first thing you need to recognize is that these are congruent signs. I don't have very many properties that I can work with in congruence, so I'm going to need to convert those to equality eventually. So let's start off with first, I want to talk with the whole segment. So let's talk about CA. So I want to say CA is equal to CB plus BA. And I know that that whole thing is equal to these two parts because of something we learned the night before, which was segment addition postulate. The two parts add up to equal the whole. Okay, and so there we have it. Next, I'm going to say here, I'm going to bring one of my given in that CB is congruent to CD. Okay, and so that is a given piece of information. All right, now that's congruent sign. I need an equality sign, so I'm going to say CB is equal to CD. And I can say those are equal because of the definition of congruence. Remember, I told you back on the first the night before, that that was going to be so important to get things from congruence to equality. Now that I know that, I can bring this other statement with that one together. It's kind of an if this and this, then this. And we know that as being substitution property. So if CA is equal to CB plus BA, I know CB is equal to CD, then these can come together and I can say CA equals CD plus BA, and I know these are equal to because of substitution property. And it takes two errors. Remember, this is an if, and then. So if this and this, then this. Okay, so I need to bring another one in here. I need the other part. I need BA to be replaced also. Excuse me. So BA is congruent to DE. And I need some segment bars over there, so it's going to be hard to see. So I'm going to put those above the top. Oops, sorry. My pens want to do a little weird stuff here. So bar here and bar here. All right, and we know they're congruent. I need them equals. So I'm going to have to do a little BA is equal to DE. Now I have no bars and I have an equality sign. Now remember, this was a given, and this is a definition of congruence. I'm going to use the symbol instead of the words. It's just faster, right? All right, and so if CA is equal to CD plus BA and BA is equal to DE, then I can say CA is equal to CD plus DE. And so I bring this one and this one together, and this is again substitution property. All right, and so I'm going to move this back up again so we can see this. So I've got CA is equal to CD plus DE. Sorry, my handwriting's a little rough tonight. All right, well, I've just proved that the segment CA is equal to the other two parts. So if I go back to the other parts, which is CE equals CD plus DE, I can see right here, right now, that first of all, that was segment addition postulate. That, let me use my highlighter here, maybe you can see a little better, that this part and this part are exactly the same now. And since they're exactly the same, I can take out that CD plus DE and replace it. So if CA is equal to CD plus DE and CE is equal to CD plus DE, I can bring those together. Let me go to my pen and say that CA is equal to CE, this one and this one together, by substitution property, because I can take out the CD plus DE and replace it with CE. Okay, and so, but I'm still, look, I want to prove that this is congruent, so I need to extend my page a little bit here. Let me go down and say that CA with a bar over it is congruent to CE with a bar over it, and that's my definition of congruence. And so this is a much longer proof. It's all these different steps coming together, and this is a big thing in proofs. And so this is the process here that we learn to use segment addition and all our different algebraic properties, but you have to be in equality to use these algebraic properties. Make sure you have this proof down. Okay, so let's look at this one. This one says that I know that ABD, which is this whole angle right here, is equal to CBE, which is this angle right here. We know those two angles are equal. What we want to prove, though, is we want to prove that ABE, which is this angle here, is congruent to this angle here. That's what we're trying to prove. All right, and so this is another nice long property that we want to have as a building block so we can work with and create other proofs. Okay, so again, start with our baseline. Now, since you don't really know where this one's going, let's start off with the fact that we know that these angles add up to equal, one whole angle adds up to equal two little angles. So let's start with that. So ABD, angle ABD is equal to, and let's put the measure here because I got the equal sign, the measure of angle ABE plus the measure of angle EBD. I know this is true because of the angle addition postulate, so I'm going to change my colors here. Angle addition postulate. I'm going to write my reason a different color, make it easier for you to see. So angle addition postulate. Now, kind of a dead end there. I don't have anywhere else to go. So let's go to the other angle. The measure of angle CBE is equal to the measure of angle CBD plus the measure of angle EBD. Okay. And I'm going to write my reason here. Angle addition postulate. All right. Now, here's what I want you to look at. All right. I'm going to use a color here. They both have that. Now, they both have that. But I also know that this angle right here and this angle right here are equal to each other because of that statement. Well, if they're equal to each other, that means all their parts are equal to each other also. And so I'm going to use a little substitution in here to make this happen. So I'm going to go back to my pen here, and I got to bring that other given in. So I'm going to say here, angle ABD is congruent to angle CBE. That was a given. I'm going to just abbreviate. Well, no, I'll just write given. It's not pretty, but we'll write given anyways. All right. Now, again, that's congruence. I don't need congruence. I need equality. So angle ABD is equal to the measure of angle ABD is equal to the measure of angle CBE. That's the definition. I want to use a different color there. Definition of congruence. So now I can bring these together. I can bring this one and this one together. So I can take out ABD and I can replace it with this whole other side right here. So I'm actually going to take out and replace it with that part. Okay. So the measure of angle ABE plus the measure of angle EBD is equal to the measure of angle CBE. And if I take something out and replace it with something else, remember, if and then, this is substitution property. Okay, now I got to do it again. I got to do it on the other side. I've got to get this into there where the CBE is. I'm going to have to extend my page a little bit here in just a second. So again, if this and this, then I got my connection. So the measure of angle ABE plus the measure of angle EBD is equal to the measure of angle CBD plus the measure of angle EBD. And that's a connection of this one with this one. And this again also is if, and then. So that's substitution property. All right. So remember, they had this one and this one in common. Well, if that's the same on both sides of the equation, remember in your algebraic properties, if I subtract from both sides, it goes away, doesn't it? So I'm going to say that the measure of angle ABE is equal to the measure of angle CBD. And I'm going to use my subtraction property, subtracting the angle from each side. Now remember my original proof up here. Remember one of those congruent. Well, I don't have them congruent, I have them equal, so I need one more step in there. And that is angle ABE is congruent to angle CBD by the definition of congruence. And there's my proof here. Each step has a reason. There's arrows connecting all of them. My reasons are all definitions, properties, or known theorems. Okay. And so these are the two main types of proofs here. And so I'll just kind of scroll it up a little bit here so that you can see this part all the way down to the end. Okay. So if you look at this last one, we took the two parts that were the same for each one of those segments and made the whole segments equal to each other. In this one, we had two whole angles that overlapped and they shared that center part together, and so we made the edges equal to each other. Okay, and so let's look at this proof. I'll go to my highlighter here. I have ABE is equal to CBD. All right, but what I want to prove is ABD, this whole thing, is equal to CBE, which is this whole thing. Well, I know the little parts are equal, and they both had that angle in the middle equal to, it's the same for both parts, so I can add these together and make these equal out. And so I'm going to run through this proof. All right. So let me get my pen up. Okay, there's my baseline. So again, I'm going to need to go with the whole angle. I need to bring angle ABD in. All right. So I'm going to start off with my angle addition. Angle AB, measure of angle ABD is equal to the measure of angle ABE plus the measure of angle EBD. Okay. And so if I'm doing part plus part is equal whole, that's going to be my angle addition postulate. Okay. And so if I go there, I kind of don't have anywhere else to go right now. But I do know that the yellow angle and the green angle are the same. So let's bring those in. Angle ABE is congruent to angle CBD. All right, and that was given information. I'm just going to put a G there. All right, for given. Well, maybe not. I'm going to write given. All right, and so, but I can't put that into the other one because it's a congruent sign. I need an equal sign. So the measure of angle A, oops, I didn't put my angle. So the measure of angle ABE is equal to the measure of angle CBD. And that's my definition of congruence. So definition of congruence. Oops. All right, now I can take out the ABE and replace it with CBD because I want to get the two angles to be the same so I can make them equal to each other. So I'm going to connect the measure of angle ABD is equal to the measure of angle CBD plus the measure of angle EBD. And the reason why I wanted to do this, and again, this is an if, and then, two things connecting. So that makes this a substitution. There's no order right here for transitive. So substitution property. Is that the other angle, let's look at that one. The measure of angle CBE, that's the whole angle, is equal to the measure of angle CBD plus the measure of angle EBD. Now remember, this is an angle addition, so it comes off the top. So I'm going to use the angle symbol instead of the word angle addition postulate. Okay, so let's look at these now. I'm going to use my mark here. This and this is the same. This and this is the same. So if those parts are all the same, couldn't I take them out of one and replace it with the other one? And so if I do that, I can say the measure of angle ABD is equal to the measure of angle CBE. This is an if, and then, because two things are connecting, which makes this a substitution property. Okay. So I've just said the two angles are equal, but I need them congruent, which means I just say the angle ABD is congruent to angle CBE. Put my box around this. And again, if I'm going from equality to congruence or congruence to equality, there's a definition of congruence. Learn these processes. They'll help you when you do some of the bigger, more complex proofs when we get into chapter 3 or chapter 4. Okay? And we've got one more left. So let's look at this one. I'm going to use my highlighter. So I've got AC. I'll pick my pen here for a second, actually. I got AC, which is this whole thing, is congruent to this whole thing. But I want to prove that this is congruent to this. Well, if I go backwards, didn't I in here have this whole angle was congruent to this whole angle, but I wanted to prove this pieces were equal to each other? This is the same proof as this one, except for this one's using segments and this one used angles. Just like this proof for the two parts were equal, we want to prove the whole thing on. This one was a little bit different. We had the edges were equal to each other. We didn't want to prove the whole thing was together, but they had the same middle angle also they could share. So we made them look a lot alike. But this proof is identical to this proof, except for it's using segments instead of angles. All right, so let's go through this proof anyways. All right, so here we go. All right, I got AC is congruent to DB, which, you know, I could start with that, but that doesn't do me any good. So let's go instead and say AC is equal to AB plus BC. That's the segment addition postulate. Okay, now why would I start with that instead of the given? Well, because this gives me something to work with. Remember I told you, some people like to say start with the given all the time. That's not true. You start with what you need. And in this case, I need something from the picture. I need some segments in there to be able to add and subtract them together. So AC is equal to AB plus BC. Got that said. Now I can bring that given in. AC is congruent to DB. All right, and that was given. I'm just going to write here, given. All right, remember that it's in congruence, so I needed an equality. So AC is equal to DB. Now that I have an equality, I can do things with it that I couldn't do before. I like to make sure you got those arrows there. So definition of congruence. Okay, and so there we have it. Now I can take out the AC and replace it with DB, couldn't I? So I could bring this together and this together, if and then. And so DB is equal to AB plus BC. Now again, if you're asking why is this important, well, I've just proven that segment DB is equal to AB plus BC. Well, let's look at the other one. Okay. We know that DB was equal to BC plus CD. We know that was true. Segment addition postulate. Well, aren't both those equal to DB now? I can bring them together. If and then. So again, AB plus BC is equal to BC plus CD. And this, if I take something out, if and then, this is a substitution property. Now, what do they share in common? Let's look at this in a different color. They both have this, don't they? And if I have that the same on both sides like I did that other proof, I can just subtract them. I can take them away. They're distances, remember? And so then I can subtract them. So I have AB is equal to CD. Okay. And so then that was the subtraction property. All right. Now, let's take a minute and look at something. I've got AB is equal to CD, but I wanted AB is equal to DC. So let's go back and fix something real quick here. I'm going to use a different color. I'm going to use black here. I said CD. Couldn't I have said DC instead? And couldn't I have taken out and replace that with DC? It's still the same length, isn't it? And so if I put this with DC, now I've got AB is equal to DC. I'm in the right order now. Does that change anything? No, but sometimes you have to go back and correct those things. All right, and so I'm in equalities. I need congruent, so AB is congruent to DC. And that will be the definition of congruence. And so there's my last proof. So I wanted you to have these 4 proofs there. They're more complex. They're used the algebraic properties a lot more. Oh, this was substitution. Look at that. We never put that in there. Okay. Have those in your notes. They're more complex proofs. We'll use them later on in other chapters. And it's good to have them there because you'll just substitute letters in to use in other proofs. And thank you.